Hello students, today we are going to discuss the index numericals of chapter 8. Here the page 100, take page 100. Second question, a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. I have drawn the square field, that is ABCD. And what about the side? It is 10 meter. Square means each side. Sorry, it is 10 meter. Now, 10 meter. Here also it is 10 meter. As it is the square, the sides are equal. Then, what will be the magnitude of the displacement of the farmer at the end of 2 minutes 20 seconds? Now, how to do it? See here. See, if the farmer moves one round around this square field, the distance covered will be equal to the perimeter of the square field, isn't it? So, we can write distance covered in one round of the field by the farmer. The distance covered in one round. I told you that's equal to perimeter of the field. You know how to find out the perimeter of a square? 4 into side, that's equal to 4 into 10 meter is equal to 40 meter. That is the distance covered in one round. Okay, now time taken by the farmer to cover one round. How much it is given there? Already given the question, 40 seconds. So time taken by the farmer to cover one round. Time taken to cover one round. (40 seconds). Now, and what about the total time taken by the farmer? It's given the question 2 minutes 20 seconds. So total time taken (2 minutes 20 seconds), that's equal to 2 minutes. How many seconds? 2 into 60, 120 plus 20, that's equal to 140 seconds. That's the total time taken by the farmer. Now, that means we can find out how many number of rounds is made by the farmer in 140 seconds. So, number of rounds made in 140 seconds. Number of rounds made in 140 seconds. How will you find out that? For one round, how much time is taken? 40 seconds. Okay, then how many number of rounds is made by the farmer in 140 seconds can be found by dividing the total time with the time taken for one round, that is 40 seconds. That's equal to 3.5 rounds. We get 3.5 is the answer. So that means in 2 minutes 20 seconds the farmer makes 3.5 round around the field. Okay, now so we can write the farmer makes, that is the farmer makes 3.5 rounds in 2 minutes 20 seconds. Is that clear? Is that clear? Now we can see in which point the farmer reaches after 3.5 rounds. See that one round complete, if he starts his journey from A, okay, then B to C, C to D, D to E. In one round complete, he will comes A. Second round also completed A, and third round A. Then 3.5 rounds. So 3 rounds completed, he reaches A. In half means where he will reach up to C only. So that the position of the farmer after 3 rounds will be at the point C. Is that clear? So we can find out what is the displacement of the farmer after 3.5 rounds or after 2 minutes 20 seconds. So we can write after 3.5 rounds he will be at C, isn't it? Therefore, the displacement is AC. The displacement is AC. How will you find out AC? You can see this is a ABCD is a square. AC is the diagonal. When you draw the diagonal, we get the right angle triangle ABC. How will you find out AC? AC is the hypotenuse of the right angle triangle ABC. So we can write in right angled triangle ABC, AC square is equal to AB square plus BC square. AB square plus BC square. Substitute the value, that is AC square is equal to 10 square plus 10 square, that's equal to 100 plus 100 will give you 200, isn't it? Therefore, AC is equal to square root of 200 can be written as square root of 2 into 100. That we can write square root of 100 it is 10, then 10 root 2. That is meter. Isn't it? That is AC. So we can write the final answer as displacement of the farmer. So therefore, displacement of the farmer from the point A to C is 10 root 2 meter. Isn't it? That's the answer. I hope second question is clear to you. Now take page 102. In 102, question 5, that is the numerical. Question 5. During an experiment, a signal from a spaceship reached the ground station in 5 minutes. That is time taken for the signal to reach. It is 5 minutes. Convert that into second. 5 into 60 will give you 300 seconds. What was the distance of the spaceship from the ground station? You have to find out the distance. And the signal travels at the speed of light, that is 3 into 10 raised to 8 meter per second. Okay, now first we can write the time taken. What's the time taken? Already given in the question. T is equal to how much? 5 minutes. 5 into 60 seconds. 300 seconds. That's the time taken, T. Now, speed of the light already given. Speed of light (3 into 10 raised to 8 meter per second). What you have to find out? Distance. We know that distance is equal to speed into time, and we already calculated speed is equal to distance upon time. Therefore, distance is equal to the formula. Distance is equal to speed into time. In the definition of speed we have done. Speed is equal to distance upon time and cross multiplication. Speed is equal to distance upon time. From this we can find out distance. Distance is equal to speed into time. Substitute the value for this speed. 3 into 10 raised to 8 meter per second multiplied by 300 seconds. Isn't it? So that will give you 3 into 3, 9. That's equal to 9 into, see here, 300, that means 10 square. 10 square into 10 raised to 8 will give you 10 raised to 10 meter. Understood the calculation? 3 into 3, 9. Here 100. 100 means 10 square. 10 square into 10 raised to 8, 10 raised to 10. And second will get cancelled. You will get the unit meter. So we can write, therefore, distance of the spaceship from the ground. Therefore, you can write distance of the spaceship. That is the final answer you have to write. What's the final answer? Distance of the spaceship from the ground is 9 into 10 raised to 10 meter, or if you write it in kilometer. How can you write that in kilometer? 9 into 10 raised to 7 kilometer. That also you can write. I hope it's clear to you. Now take page 103. Page 103. Note down the page number properly. Page 103. Question 2. Second question. That's a numerical. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Okay, so what is the initial speed of the bus? So initial speed, note down the data which is given. Initial speed we denote using the letter U. That's equal to 80 km per hour. Convert that into meter per second. 80 into 1000 upon 3600 meter per second. Now, that can be written as, simplify that. 0 and 0 gets cancelled. Then, here, 4 2s are 4 9s are. Isn't it? So, we get the answer 200 upon 9 meter per second. Now what is given then? Final speed, that is V. Final speed of the bus, that is V, is equal to how much? It is 60. 60 km per hour, that's equal to 60 multiplied by 1000 upon 3600 meter per second. Find out the answer then. Simplify the same method. 0 0 gets cancelled. Isn't it? Now again simplify. With which number you can simplify that? So let it be with the denominator 9. I am going to find out. So see here 60, let it be 0 cancel. Okay. Then with 4 only. 4 9s are 15. Here also 9. Here also I want the denominator 9. That's why I did the simplification in this way. So you will get 150 upon 9 meter per second. So our calculation will be easy by finding out the acceleration. And time, what is given time? Time is equal to 5 seconds, isn't it? And we know the formula to find out acceleration. Acceleration A is equal to V minus U upon T, isn't it? That's equal to, what is V? 150 upon 9 minus 200 upon 9, that's the initial velocity. Then what about the time? It is 5 meter per second square. That's equal to, see here, 150 minus 200. Denominator we can make the same, 9. So we get minus 50 upon 9 from 5 meter per second square. That's the unit. Write the unit there. So fraction minus 50 upon 9 into 1 upon 5. That's equal to 5 ones are 10 minus 10 upon 9 meter per second square. That is the acceleration. Minus 10 upon 9 meter per second square. And you can divide minus 10 with 9. What answer you will get? 1.11. That's equal to minus 1.11 meter per second square. Okay, calculate and then write the answer. So here we can final answer. What will you write? Therefore, acceleration of the bus is equal to minus 1.11 meter per second square. Here the previous second one, why you got the acceleration negative? Because the velocity decreased. That's why the acceleration is negative. Now the third one. Third question. A train starting from a railway station and moving with uniform acceleration attains a speed 40 km per hour in 10 minutes. Find its acceleration. So as a train starts its journey, you know that the velocity will be 0 from the beginning. So initial velocity u is equal to u is equal to 0 meter per second. And next what is given? Time t. What's the time? T is equal to 10 minutes. That's equal to 10 into 60 seconds. That's equal to 600 seconds. That's the time taken. Now, what's the final velocity v? Final velocity how much given? 40 km per hour. Convert that to meter per second. 40 into 1000 upon 3600 meter per second. That's equal to, cancel, isn't it? So 100 upon 9 meter per second. That's the final velocity. So we know that how to find out acceleration. A is equal to v minus u upon t. What is v? 100 upon 9, u 0. What about t? 600 meter per second square. That's equal to 100 upon 9. See, I'm going to do it directly. Divided by 600. 100 upon 9 minus 0 means 100 upon 9. Divided by 600 means multiplied by 1 upon 600. The answer you will get 0 and 0 cancel. Here also 1 upon 54 meter per second square. So what is the acceleration? Therefore, acceleration of the train is equal to 1 upon 54 meter per second square. Only you have to substitute the values in the equation. Formula you know how to find out acceleration. Change in velocity upon time. So substituting the value, we get the acceleration of the train as 1 upon 54 meter per second square. So next page 109. Page 109. The first question in that. A bus starting from rest. So starting from rest means initial velocity u is equal to 0, and that moves with a uniform acceleration of 0.1 meter per second square. A is equal to 0.1 meter per second square. Time t is equal to 2 minutes. That's equal to 120 seconds. What you have to find out, find the speed acquired and the distance traveled. Very easy to do it. So we already studied the equations of motion. Select the equations of motion in which the given data can be substituted. So here, so first you will write initial velocity u is equal to 0 meter per second. Then what is given? A is equal to 0.1 meter per second square. And then t is equal to 2 minutes. That's equal to 120 seconds. So first you have to find out the speed acquired. Speed acquired means the final speed. So using the first equation of motion v, we know the first equation of motion v is equal to u plus at. See here, u is there, a and also t given. So we can substitute the value 0 plus 0.1 into 120. Isn't it? That's equal to 12 ones are 12. So 12 meter per second. 12 meter per second. Isn't it? That's the speed which is acquired. Okay. Now, what you have to find out next? The distance traveled. You know that equation of motion for finding out the distance traveled. That is distance time relation. So S is equal to ut plus half at square. That's equal to 0 multiplied by what is t? 120 plus half into 0.1 into 120 into 120. 0 into 120 plus half into 0.1 into 120 into 120. That is meter, as it is the distance. Okay. That's equal to 0 plus 2 and 120 gets cancelled. 60. What's the answer then? 12 6 are 72. 72, 2 zeros, isn't it? Here how many decimals you have to remove? 1 decimal. So you will get the answer 720. The answer will be 720 meter. That's the distance travelled. So what will you write as the final answer then? Therefore speed. So you will write here A. What will you write? Speed acquired 12 meter per second and distance travelled 720 meter. This is the final answer. Okay. Now take page 110. 110. Second question. A train is travelling at a speed of 90 km per hour. So u is equal to 90 km per hour. You can write that is the initial speed. So u is equal to 90 km per hour. That you convert it into meter per second. So that's equal to 90 multiplied by 1000 upon 3600 meter per second. See here 0 0 cancel. 9 ones are 9 fours are 4 1 here 25. So you will get 25 meter per second. Okay, now brakes are applied so as to produce a uniform acceleration of 0.5 meter per second square. So brakes are applied, isn't it? That means the train comes to a stop. So we know that the final velocity v will be equal to 0. And as the brakes are applied, the velocity is decreased. So acceleration given, a is equal to how much? 0.5 meter per second square. As the velocity decrease, acceleration will be minus. So minus 0.5 meter per second square. That's the acceleration. Now, what you have to find out? How far the train will go before it brought to rest. Here, initial velocity, final velocity and acceleration given. You are asked to find out the distance traveled. So we will use the position velocity relation to find out the distance traveled. What's the position velocity relation? 2as is equal to v square minus u square. Substitute the value. 2 into minus 0.5 into s is equal to 0 square minus 25 square. Isn't it? Then we can write minus 5 2s are 10. How many decimal? 1 decimal. Minus 1 s is equal to minus 25 square. Isn't it? Minus s is equal to minus 25 square. Therefore, both the place minus, isn't it? Therefore, s is equal to 25 into 25, that is s is equal to 625 meter, isn't it? So, s is equal to 625 meter. So, we can write that is, what's the final answer then? That is, the train will cover a distance of 625 meter before it comes to rest. Is that clear? That is, the train will cover a distance of 625 meter before it comes to rest. Now the third question in page 110 only. Third question. A trolley while going down an inclined plane has an acceleration of 2 cm per second square. What will be its velocity 3 seconds after the start? So what is the initial velocity given? So as it is starting, isn't it? So initial velocity u is equal to 0 cm per second. And what is the acceleration? 2 cm per second square. So acceleration it is 2 cm per second square. And what about the time taken? You have to write it in statement. Initial velocity u, acceleration a, then time taken t is equal to 3 seconds. So here we can use the velocity time relation, that is v is equal to u plus a t. Substitute the value. What is u? 0 plus 2 into, u plus, yes, 2 into t, that is 3 seconds. 3 meter per second. That is v is equal to 0 plus 6 meter per second. That is v is equal to 6 meter per second. So what can you write? What's the unit here? Centimeter. So it is centimeter, not meter, centimeter. Here also centimeter, centimeter, here also centimeter. Because here acceleration is given in centimeter per second square. Is that clear? Now final statement, what will you write? The velocity of the trolley after 3 seconds. So therefore the velocity of the trolley after 3 seconds will be 6 centimeter per second. That's the answer. Now question 4. In question 4, a racing car has a uniform acceleration of 4 meter per second square. What distance will it cover in 10 seconds after the start? So here the initial velocity. What's the initial velocity? As it has not yet started, so initial velocity u is equal to 0 meter per second. And what about the acceleration a? 4 meter per second square. What distance will it cover in 10 seconds after the start? You have to find out the distance the car will cover after how much time? 10 seconds. So here which formula, which equation you will use? Position time relation, that is S is equal to ut plus half at square. Substitute the value 0 into 10 plus half into 4 into 10 into 10, isn't it? That's equal to 0 plus simplify. Answer will be 200. Distance it is in meter. 200 meter, that's equal to 200 meter. S is equal to 200 meter. So we can write the car will cover, that is the car will cover a distance of how much? 200 meter. Is that clear? Now the fifth one, same page. A stone is thrown in a vertically upward direction with a velocity of 5 meter per second. So initial velocity 5 meter per second. Okay, now if the acceleration of the stone during its motion is 10 meter per second square in the downward direction, what will be the height attained by the stone and how much will it take to reach there? So, and see here, a stone is thrown vertically in the upward direction. So you know that as it is moving in the upward direction, the velocity goes on decreasing. So the final velocity V will be equal to 0 meter per second, isn't it? And then we can write acceleration, upward direction, velocity decreasing, acceleration A is equal to, how much is the acceleration given? 10. So it is minus 10 meter per second square. So why is the acceleration negative here? As the stone is moving in the upward direction. So, and velocity at the highest point it will be 0. So we can find out the time using the equation V is equal to U plus AT. That is 0 is equal to 5 plus minus 10 into T. Isn't it? This taking to minus 10T, taking to the left hand side we get 10T is equal to 5. Therefore, T is equal to 5 upon 10. That's equal to 1 upon 2. That's equal to 0.5 seconds. 0.5 second is the time taken. So, next what you have to find out? What will be the height attained? So, here we can use the third equation of motion, that is the position velocity relation. Position velocity relation. V square minus U square is equal to 2AS. So what is V square? It is 0 square minus 5 square, substituting the value 2 into A minus 10 into S. Isn't it? Otherwise you can use S is equal to UT plus half AT square also. Then that is minus 25. 0 minus 25, that's equal to minus 20 S. Therefore S is equal to minus minus get cancelled. We get 25 upon 20, that's equal to 5 upon 4, isn't it? Find out, divide 5 with 4, that will be S is equal to 1.4 ones are 4, isn't it? And then 1.25. Finding difficult then, see here. 2, 8, 20, 5, 20, isn't it? So that is meter. Now what will you write as the final statement? The stone will reach the height of 1.25 meter and the time required it is 0.5 seconds. So we can write the stone will reach a height of 1.25 meter and the time required is how much? 0.5 second. 0.5 second. And now see the numericals of in-text questions. It is solved. The question answers I'll send to you. In the next video, we will solve the numericals from exercise. So by that time, practice the index numericals and also the numericals which are given as examples in your textbook. Thank you.